Hello, Math Humans. We're going to do 1.4 today. We're going to be looking at statistical studies and trying to discern whether or not they are believable. So our objectives are that we're going to critique studies for believability. So when we're conducting a study, there are some things that we need to do, and then when we are critiquing that study, we want to see if these parameters have been met while we look at the study. Number one, if you're looking at a study, was a goal stated? Okay, and was that goal stated clearly? Or did they use language that's really hard to understand? Is the wording precise? And then, is there any tricky wording? And we're going to see an example of this in a little bit, and then we'll talk about the effect of that tricky wording. Okay? The next thing that you want to look at when you're looking at a study is the population and the parameters that they used. Okay? And again, we're looking for things that are clearly stated. And then when we're talking about the population, is the population representative? And then do they have a broad base? So an example of this would be political studies. And who are they using as their population? So if I'm looking at a particular party, right, there are jobs that tend to be heavily biased in particular parties. So am I doing a broad group of people so that I can get an accurate representation? Okay? So I want to know, does my population really reflect a broad group of people? Okay? The next thing that we're going to look at for number 3 is the source of the study is stratified. Okay? And here's an example of what that means. So if we had an example, maybe I have a study showing that there is no global warming, and maybe that study is financed by the oil industry. Okay, so you can see that there might be a conflict of interest. So stratified means, is there a conflict of interest, or is it done by a non-biased third party? Another example would be, maybe it is a study showing the advantages of solar panels, and when you look at the fine print on the study, you'll notice that it was financed by a solar panel company. So you always want to make sure that the person that's funding the research is not the same company that is in the study that you are trying to do some work on. Okay? The next one is called the confounding variables. And so I'm actually going to bring in an example from your book, and you don't have to write this down, but I would like you to write down your thoughts after we go through the examples. So for confounding examples, okay, this is going to be the example. So it says that study was done to show that microwave ovens were dangerous. So we're looking at microwave ovens, and we're going to do a study involving plants, where one plant was given tap water and one plant was given water that was boiled in a microwave oven. Okay, so at least to me, it seems like the parameters of the study are a little bit entertaining. The plant that was given water that was boiled died. So the conclusion would be that the microwave caused damage to the plant. But really, the reason that the plants probably died is that they poured boiling water on the plant. So if you're know anything at all about plants, they don't like boiling water. So it really didn't show that the microwave oven was dangerous. It just showed that plants don't like boiling water. Okay, so that's kind of what we talk about confounding variables. So number 5, we're going to talk about bias. Bias is a bad word in statistics from the sampling method that's used. Alrighty, and so for this, maybe it means selection bias. And what they mean by that, an example would be, let's say I want to ask questions about owning a cell phone. But the only people that I ask, so the only people surveyed are cell phone owners, right? So I know that it would be really hard to do a study in today's day and age where somebody doesn't have a cell phone, but you want to make sure that you're actually choosing a broad group of people to sample and not just somebody that's got what you're trying to prove. Another one is called a non-response bias, and I actually think this one, if I spelled it wrong, is a little bit entertaining. So what this one might mean is, let's say you're going to do a survey and you're going to send out 10 million surveys. Whew, that's a lot of surveys, okay? Well, maybe only 2 million surveys came back, okay? So if you do the percentages, 2 divided by 10 is only going to be 0.2. So only, I'm going to change this into a percentage, 20% of the surveys came back. So really, although 2 million is a big number, you only got back 20% of the surveys that you sent out. So if you proceed, if you go ahead with the study, it looks like you really had a big study and you really had a big group of people, but in fact you really only got 20%. The next one, number 6, let me move my paper up, is going to be called the setting of the survey. And this one cracked me up when I read it. So I'm going to bring in my notes again so we can see that one, okay? And so we're going to be looking at the setting. So it says, suppose the survey is being conducted to learn more about illegal drug use among college students. And when you go to college, you're going to find all kinds of things that you never knew happened. But what if a uniformed policeman is the human that's conducting the survey? The results are going to be extremely biased because you know the college students are going to feel uncomfortable telling a police officer that they're doing illegal drugs. So you want to make sure that you're not asking people questions by someone that's going to have a vested interest in the response. Okay? All right. Number 7 is going to be the wording of the survey. And this is a huge one. So if you'll think about the surveys that you guys get as students at Flag High, and oftentimes students will be asked to fill out a survey. And there's a lot of thought that goes into how the survey questions are worded because oftentimes the survey questions bias a particular response. So here is an example. And again, you don't have to write all of this down, but I want you to understand how the wording can be deceptive. So the first question says, do you think that global warming is the most important world environmental issue or pollution of the oceans? So in this one, pollution of the oceans is like an afterthought, like, oh yeah, maybe this is something you should consider. So they're saying that this is going to be the primary thing that they want you to think about. So if you change the wording a little bit, and it says, do you think that pollution of the oceans is the most important? So again, here's the thing that they want you to respond to, or maybe global warming. So again, in this one, global warming is the afterthought. So you always want to be very critical of the questions that are being asked. This is probably the best way to ask this type of question because it doesn't build any bias into the question. And so this one says, what do you think is the most important world environmental issue? Is it global warming? Is it pollution of the oceans? Or is it other? So in this one, it seems like all of the options have the same effect. Okay? The eighth thing that we want to cover is a wrong conclusion. So integrity, meaning are you truthful or do you do what you say you're going to do, is often in question when we talk about a wrong conclusion. So, for example, many studies have been done on rats about cancer. Okay? And then we tend to test rats with things because we want to test them first before we test humans. But let's say that they developed a new treatment, and that treatment was effective on the rats. Yay for the rats. But is that same treatment going to be effective for humans? So although it gives us a good place to start with a new treatment, we can't immediately go out and say that it's going to be effective on humans because they have a different physiology and maybe the results aren't going to be the same. So it gives us a place to start, but we can't immediately jump to the fact that maybe it's going to be effective in humans. The next one, math, is absolutely one of my very favorite, and I actually have a couple of examples. You don't have to write down the graphs, but I want you to understand. So oftentimes, graphs can be misleading, and so maybe we change. I love to write the triangle to mean change. Maybe we change the scale on each axis. Maybe we change the scale and don't start at 0. Now we're going to talk more about this in the next section, but I'm just going to give you some examples. Maybe we leave off words or titles or units, and you'll see what I'm talking about when I bring up the examples. So I have a couple of examples for us. So I'm going to try to bring up the example. Okay, I think in theory you can see my example about shark attacks. So I just started looking for examples that talked about funky statistics. So notice I have a title on this axis and I have a title on this axis. But this is a report talking about shark attacks by state. Okay, so it looks like, holy crap, I would never go to Florida because I'm going to get eaten by a shark. But the thing that's interesting is each of these states, so Alabama, California, Florida, Georgia, Hawaii, Texas, all have different coastlines. So some of them have more coastlines than the other. Some have different water temperatures than others, so that means that sharks maybe are more likely to go to a warmer water than to a colder water. Okay. Some of the other issues that might be missing is some of these places are destination beaches, and some of these places maybe are not. And so it's really hard to say that this is an accurate representation of the data. Okay. All right, another one, which is really entertaining, and this one is number 10. So these are our final thoughts. You always want to question the integrity of the organization that's putting out a study. Okay, here is a misleading graphic, and I think this is hilarious. So it's asking people what their favorite food is, and they had 14 people that voted. These two graphs both represent the exact same data, but notice that This one on the vertical axis, on the y-axis, it starts at, and I know you can't probably read that number, but it starts at 950. This one starts at 0. This one would make you think that hot dogs are significantly more favored than pizza or hamburgers, but if you start the graph at 0, then you'll see that there really isn't that much of a difference between the three different types of food: hamburgers, hot dogs, and pizza. So depending on how I set up the data, I can skew the results and I can make people jump to conclusions, because unless we're really paying attention to the details, we might miss excuse me, some important information. Alrighty, that's it for today. I will see you soon.